Dynamic programming. Dynamic programming is a powerful algorithmic paradigm used to solve complex problems by dividing it into smaller subproblems. But the same is what we said in case of divide and conquer. When we learned about divide and conquer, we said it is used to solve complex problems by dividing it into smaller subproblems. Then the question is, how is dynamic programming different from divide and conquer? Or what is it that makes dynamic programming capable of solving those problems which are not handled correctly by divide and conquer? The answer lies in the key idea behind dynamic programming. What is the key idea behind divide and conquer? The key idea is to divide the larger problem into smaller problems so that solving the smaller problem becomes an easier task, and then once you complete solving the smaller problem, you will merge all those solutions back in order to get the final result. This is what you did in divide and conquer. But in case of dynamic programming, the key idea is to avoid redundant computations. How does these redundant computations occur here? Redundant computations occur because in case of the problems that you tackle using dynamic programming, whenever you divide the main problem into smaller problems, each of those smaller problems will be having a lot of even smaller sub-problems which are repetitive. That is, if you solve this part, that is this sub-problem completely, you will be facing many smaller problems which you will face while solving this sub-problem as well. The same set of smaller problems you will face while you are solving this sub-problem, and so on. So when you are solving different sub-problems, you will be facing a lot of even smaller problems which are repetitive. That is, the same problem occurs while solving all these sub-problems. In order to tackle this, what will you do in dynamic programming? You will store all these computations. That is, whenever you do some computation, when you solve a smaller problem, you will always store all those results in a table. How is this helpful? Whenever you have to make the call to the same function using the same input values, you know this is already computed. So what will you do? Second time, you are not going to compute it. Instead, you will directly fetch the value from this table. This is how all the redundant computations are avoided by dynamic programming. So dynamic programming is useful only in those cases where you have redundant, repetitive computations, right? Let us understand this with a simple example. That will be easier, okay? Let us say you want to compute nth Fibonacci number. What is Fibonacci number? You know about the Fibonacci series, which starts with 0, 1, and then how do you identify the remaining Fibonacci numbers? In order to find nth Fibonacci number, that is any Fibonacci number, you have to use this formula f of n minus 1 plus f of n minus 2. That is, any Fibonacci number is the sum of previous two Fibonacci numbers. So if you want to find nth Fibonacci number, you will add n minus 1th Fibonacci number and n minus 2 Fibonacci number. This is what you want to do. Other than first two, that is f of 0, this is fixed as 0, f of 1 is fixed as 1, and for the remaining Fibonacci numbers, you have to use this formula. So if you want to find the next Fibonacci number, how will you do? It is 0 plus 1, which is 1. The next one, how do you find it? 1 plus 1 is 2. What about the next? 1 plus 2 is 3. Then 2 plus 3 is 5. Then 3 plus 5 is 8, and so on. So this is how your Fibonacci series goes on. If you want to find out the nth Fibonacci number, let us see how the recursion call will happen. You will have to make one recursion call to f of n minus 1 and one recursion call to f of n minus 2. Let us say you are finding fourth Fibonacci number. We are taking a small one so that it is easier to understand. If you want to find f of 4, you have to make two computations. One recursive call will go to find f of 3 and the other recursive call will find f of 2. Once you have both these answers, you can add f of 2 and f of 3 in order to get f of 4. So how will you find this f of 3? For this, again you will make two recursive calls. One is for f of 2 and the other is for f of 1. What about this f of 2? For this, again you have to make two calls to f of 1 and f of 0. The same is the case with this f of 2 as well. You have to make f of 1 call and then f of 0 call. When you're using dynamic programming, what happens is, whenever you make these calls and you get the final answer for those calls, you will store it in a table. So you will have a table here, and in this table, you will keep storing the values that you are computing. Let us say you made a call to f of 4. So it will recursively call f of 3, f of 2 and f of 1. Whenever you reach f of 1 and f of 0, you know these are already fixed and you can directly find. Then you will be able to find f of 2 because it is addition of f of 1 and f of 0. So whenever you find this f of 2, you will store it in the table. What is the benefit of this? Next time when you make the same call to f of 2 in a different branch, you don't have to again call f of 1 and f of 0. Instead, you will directly say that I remember that I already made this computation and I've stored this value in a table, because of which I can directly fetch the value from the table and use here. What is the advantage? You saved some additional recursive calls. So here if you just see, you can see there are multiple calls to f of 2, multiple calls to f of 1. Here also you had an f of 1 call. So similarly, whenever this problem gets bigger and bigger, that is, let us say instead of f of 4, you made a call to f of 100. Just imagine if it was f of 100, then how many calls would have happened to f of 2? Because each of the sub branches will repeatedly again and again and again call f of 2. Not just f of 2, all the higher numbers 3, 4, 5, 6, everything up to 100 will be called multiple times. So if you use normal recursive procedure, you will be calling the same function with same input again and again and again, and this will take your time complexity to order of 2 power n. Why is it 2 power n? Because the number of times you are making these calls will go to exponential time complexity. It will be order of 2 power n function calls that you are making. With the help of dynamic programming, what are you going to do? Each time you make the function call, you are going to store, which means next time if you are making the call, you are going to directly fetch the value, and that won't take any time, because of which this order of 2 power n will come down to order of n. So instead of order of 2 power n function calls, in case of dynamic programming, you will only make order of n calls, because you will save a lot of recursive calls because of this table. So this is the idea behind dynamic programming. In simple terms, you can understand it like this. Let us say you are a hotel receptionist. If you are a receptionist, and let us say you will get calls asking for any room availability. So you got one call and you checked for the available room that was asked, and let us say this particular room was already occupied, which means you have to respond saying the room is not available. And what if again after, let us say 10 minutes, you are getting a call from a different customer asking for the same kind of availability? Will you again go and check whether that is available, or will you directly respond it? This is what dynamic programming also does. Instead of again going and checking, you already checked once, so you will remember that last time when I checked, it was not available, and I know it is not available for this day. So I need not go and check again. Instead, I can directly respond to the customer saying this particular room is not available. The same process that a human being will do in these sort of scenarios, this is what we are implementing in dynamic programming. If you are actual human being, you are doing this sort of a solution, you will remember that I already solved f of 3, so I don't have to solve it the second time. I already solved f of 2, because of which I don't have to solve again. The same way, in dynamic programming, you are making the computer store all the values and remember the values. So next time when it is computing, it will directly compute, directly fetch instead of computing. What is the advantage? From order of 2 power n, which is exponential time complexity, you are going to take it down to order of n. So this is why dynamic programming is very, very important, because the reduction in time complexity that is brought about using dynamic programming, that is substantial. So this is the reason why dynamic programming is important. Next thing is, let us understand what are the key characteristics that you want to see in a problem in order to identify this as a problem which can be solved using dynamic programming. This is important because whenever you want to use dynamic programming, first thing is you should know whether this problem can be solved using dynamic programming or can it not. Once you know this, you can apply dynamic programming. So what are the two key characteristics that you have to see in any problem in order to identify that this can be solved using dynamic programming? The first characteristic is overlapping subproblems. Overlapping subproblems. What is this? We already told that when is dynamic programming useful? It is useful when the main problem has a lot of subproblems which are having smaller subproblems which are repetitive. So that is what you meant by overlapping subproblems. Overlapping subproblems means the subproblems that you have, they all overlap. That is, there are many smaller problems inside each of those which are required in common. All those subproblems need many smaller problems in common. They are overlapping. So whenever you have overlapping subproblems, that means the problem can be broken down into smaller subproblems that are solved multiple times. So the point multiple times is important here. Whenever you have such problems, instead of solving the same subproblem repeatedly, what will you do? You will use DP, which will store the results, and these results are used to avoid redundant computation. So the first characteristic that you should have is overlapping subproblems. If you don't have this, then there is no point in storing. If you are anyway solving each subproblem only once, then there is no point in storing those. The next thing, second characteristic is optimal substructure. What is optimal substructure? You heard this term even in the previous examples also. So that is in case of divide and conquer, there you had seen optimal substructure. Even in greedy you had seen optimal substructure. What is optimal substructure? Optimal substructure means optimal solution of a problem can be constructed from the optimal solution of its subproblems. So this is a common characteristic that is there in both divide and conquer and also dynamic programming. That is, whenever you have a larger problem, the solution to that larger problem should be such that you can obtain it by finding the optimal solution for your smaller subproblems. What makes dynamic programming different is the quality of overlapping subproblems. Okay. So now you know what are the characteristics to see in order to identify this as dynamic programming. Next thing is, what are the steps to be followed if you want to solve a problem using dynamic programming? If you identified that it is a dynamic programming problem, then once you step into solving the problem, what are the steps you should follow in order to solve this problem using dynamic programming? So the first step, as always, is to define the problem and to identify subproblems, right? Identify subproblems. This is the first step that you have to do. This is basic. Even in any of the algorithmic paradigms, you have to define the problem and identify the subproblems clearly. Second thing is to formulate the recurrence relation, right? You want to find the recurrence relation. Understand that whenever you have a dynamic programming problem, this is such a problem which can actually be solved by plain recursion, but solving it using plain recursion takes a lot of time. That is, you have a larger problem for which you can make multiple recursive calls like this, and these calls will keep growing and it will keep growing exponentially, because of which your time complexity will be very high. So what will dynamic programming do? It will help you in reducing the number of recursive calls. So the first thing is you should formulate the recursive relation, that is the recurrence relation should be found out. That is, what is recurrence relation? Expressing the solution in terms of its subproblems. That is what you call as recurrence relation. Whenever you have a solution of the larger problem, that should be expressed in terms of some of its subproblems. Once you have this, you have the recurrence relation. Next thing, this is what is going to define dynamic programming. That is, you have to choose a storage mechanism. What is storage mechanism? You either use a top-down storage mechanism, which is called memoization, or you use bottom-up storage mechanism, which is called tabulation. About both these techniques, we'll separately discuss in the coming lectures because these are very important concepts. So the third step in dynamic programming is to identify the right storage mechanism that you want to use, because storage is the core of dynamic programming. Otherwise, you can simply use a recursive relation. Here, the difference that dynamic programming brings in is because of storage. Then what should you do finally? Once you have done this, you identified all the major components, you can start writing the code and you can implement. So this is the simple way in implementing a dynamic programming solution. So one thing I want to tell you is, many times students think dynamic programming is something very difficult. It is something so special and tough to understand. What you have to realize is, dynamic programming is just an optimization over plain recursion. That is, whenever a recursive solution is making repetitive calls on the same input, you can simply apply dynamic programming to that repetitive solution so as to optimize it. So what you have to keep in mind is, if you can write that recursive solution, that automatically means you can also write dynamic programming solution. It's just a way of understanding it. Once you understand it, you will realize that it is just the same recursive solution, but you're just simply storing some value somewhere. Which means if you know recursion, by default you know dynamic programming as well. There is no need to think of dynamic programming as something which is very difficult or something tough to understand. Instead, if you see it as simple recursive solution, and then I understand that you are storing some of the subproblem solutions separately, that is what you call as dynamic programming, then writing the dynamic programming solution also becomes easier. So in the coming lectures, we'll clarify it, how you can write a recursive solution and how you can easily convert it into dynamic programming. So there are a lot of dynamic programming algorithms. For example, longest common subsequence. This is a classical dynamic programming algorithm. Another one is Bellman-Ford algorithm is there is Floyd-Warshall algorithm. You have matrix chain multiplication. So we'll see all of these problems in the coming lectures. There is 0-1 knapsack, which is another classical dynamic programming problem. We'll see about all these problems in the coming lectures.